Hello. Wow. At that late hour on this day, thank you for joining me. I honestly wasn't expecting that many people still hanging on the conference. Usually the people are just taking off, heading home. So thank you for your time this afternoon. My name is Andrzej Kubik. I work for Splunk as a product architect, product manager, and I am specifically focusing in Splunk on the observability space and the area of the observability called getting data in, or GDI. So when I am not doing these talks and when I am not meeting with the customers or trying to kind of figure out how to do things best, I am like spending time on other activities and just trying to kind of be as much active as possible. All right. I have a standing contest with one of my colleagues doing also some of the speeches. So who is going to say the most corny joke ever during the conference in front of the people? So for now, I see a lot of you, so I have a chance that I will actually win this contest. So why should you buy a coffee machine with the Wi-Fi support? To get the regular Java updates. Oh, come on. All right. There will be at least one more, right? I won't let you go that easily. All right. So this presentation is about the observability. It's also covers specifically the OpenTelemetry aspect of observability. Then we will also talk about, I will talk about why OpenTelemetry should be the first consideration when choosing the observability solution, which is usually not, and what you can do with the Java ecosystem and observability today using OpenTelemetry. And ecosystem is an important word, which we'll get to in a sec. We will not go through any basic examples of running two lines of code, one for starting the Java agent, the second to add the manual instrumentation to the agent, because it's so simple. I think you can find it on your own very easily. There are tons of workshops and materials that you can use. I will try to avoid doing any product marketing as much as possible, although I will touch on at least two solutions just for comparison. So hopefully this will be useful. When we are talking about observability, we are usually thinking about monitoring. Then observability also kind of sometimes interchange with that monitoring. There is an instrumentation, which is also a word related to the whole topic. And then there is also telemetry. But actually, as I will try to convince you through this talk, that the context is everything. All those pieces, all those terms that you see here are not that useful without the context. And as always, there is some sort of an analogy to compare the monitoring versus observability. And people use cars, usually I use planes. So imagine a plane that is flying from one place to another. As it goes, it is kind of followed by a series of stations on the ground called air traffic controls, who are trying to basically observe and monitor what is happening with that plane. Usually they get a very basic data like altitude, maybe speed, maybe heading. They get it from the radar, they get it from transporters. They can talk to the pilots who can give them some updates. As the plane goes, lots of those stations will try to basically take care of the plane, know what's happening. Similar on approach and on takeoff and landing, there are some additional procedures that are taking place. And all of that can be referred to as monitoring. So they know basics, they are trying to get some of the information. Quite often this is done in different places. That's monitoring. It can get fancy if you know if somebody has access to the latest technologies, they can get a little bit more information using some additional data. But typically, the ATC is not like that. So that's the ATC. ATCs are basically almost everywhere. Then pilot themselves are actually doing the monitoring as you would probably know it. So they have dashboards, they have all the kind of meters, dials, instruments to tell them basically what's currently happening with the flight. With the flight, right? So where they are, how they are heading, what's the speed, how the engines are operating. But that's usually not their main job, right? They are not focusing that much on how the plane works. They are focusing on basically making sure that the plane gets from A to B. That's also monitoring. That's monitoring in a more modern fashion, right? So today, with your systems, you can probably do monitoring using some kind of a sophisticated analytics. You will get nice dashboards. You will see lots of data. Quite often, that data is related to here and now, and well, that limits also the kind of the visibility of how much what you can do with this data, especially in case of troubles. And then lots of like airline or kind of a craft companies building craft vendors, they offer something called operations center. And operations center are basically pulling the information from the planes as they fly. They are collecting lots of information, usually via satellite. So this is not just from the ground, it's actually going through the satellite, so technically the pipelines are higher. And they are getting all kinds of insights, not only about how the plane is doing in flight, where it's on its trip from A to B, but also information about how the engines are performing, what are the insights from those engines, whether there are any problems heading up, how to correlate. They have time and enough of data to correlate the information about the engines, APUs, fuel levels, and a couple of other instruments that they have on board in the complex machine as the airplane is. And basically what they are doing is they are trying to draw as much of insights from all of that data as possible to get to conclusion that something is wrong happening with the plane. And then that gives them ability to react faster and quite often also inform the pilots that some actions needs to be taken. There is no yet remote control for the planes, but technically it would be possible, but it's not yet allowed. But that would technically be possible to even for them to take over the plane and fly on their own. Same concept as drones. So monitoring is like a typical technique of getting information what's happening with the system. It allows to take a measurement of what's happening here and now. The observability will go more into depths of how things are working together. What's the extent of operations? How those operations from different components are coming together? And observability allows us to understand not only what's happening here and now from some kind of a high-level perspective, but also go deeper and find specific problems. And observability is not something that is new. So that's not something that came to be, here and now and was produced by some of the vendor or something. This is a kind of a consequence of a couple of decades now of software development and tools and building tools and different techniques, protocols. Some of them are listed here. That's definitely just kind of a portion of this. Using different methods to get the information from the running systems, quite often large distributed systems, and trying to get a better kind of information on what's happening and react quicker so those systems can operate well. And observability is a term that is kind of gathering all those concepts to name something that we're currently trying to do. So not only have those small kind of tools and protocols and techniques, but also somehow to correlate that information and draw insights out of this. Typically in the organization, we have, especially like mid-size, large organizations, we have number of teams. And honestly, believe me, it's like 90% of organizations I work with have this problem in smaller or bigger extent. So they have lots of different areas, teams. Some of them are development teams, engineering teams. Some of them are operations. Others are quality assurance. Then there is a whole slew of the business functions, from product management through marketing and I don't know, finances. There are support teams, and there are teams who are managing the third-party solutions and other things. And somewhere down in the basement, there is also cybersecurity ops team who is trying to secure the system from problems. All of those teams will use some of those aspects of observability or monitoring in one way or another. But quite often, those tools will be just a siloed version of like a full visibility. But funny thing, they are working on one system, right? So each of them is looking at the system from a different angle, trying to draw insights. But lack of context, right? So lack of ability to take that information and connect, it's eventually leading to something that we can refer to as messability instead of observability. It's very difficult to find out what's happening, very difficult to connect the information. Support process take ages, customers get angry. And if you haven't been on the calls when your manager is screaming at you that the problem is already out there for 3 weeks and nobody has been able to resolve, that's usually the consequence of something like that. The ability to connect that information together is core for the observability. If we don't have the ability to interconnect that data, we'll be always having issues with understanding basically what's happening in the systems. And even more with the current systems, which actually got more complex than they were before. After context, there is something called semantics, which is basically just the description, how to describe in a uniform way the systems that we are trying to monitor or observe. But that's a completely different topic. So the OpenTelemetry. Probably some of you heard about OpenTelemetry in this way or another. Maybe some of you didn't hear or didn't have any kind of experiences with this. OpenTelemetry is a project that was created 4 years ago now under the Cloud Native Computing Foundation as an attempt to convert some of the existing tools and existing concepts like open census, open tracing. Some of you may have heard about this. Take some of the concepts related to how we are processing metrics, like probably you heard about Prometheus and basically the powers that it has. Some things related to log processing and how to connect them in such a way that actually together they have a much more powerful usage. So that project was created. Actually, right now, there are near to 75 companies who are actively contributing, 900 developers. It's the second biggest project in CNCF portfolio. And it's also the second most active project, right? But big meaning number of contributors is not always equal to how much contributions go to the project every day. It's actually done by vendors of observability, cloud providers, as well as the customers of observability or users of the observability alike. Some of the names mentioned here, but obviously the list is bigger. So if you can take a look at this activity, and the interesting thing is that CNCF also is behind the Kubernetes. Kubernetes is obviously the most active project of that organization among dozens of others. But then the OpenTelemetry is on the second place and it holds that position for now for two or 3 years now. With the OpenTelemetry, we need to move to the pillars of observability, and this is basically, so I mentioned Open Census and Open Tracing. There is also kind of a whole area of logs and open source tools around logs and processing logs. The OpenTelemetry focuses on, or started focusing on those 3 first pillars. So traces, metrics, and logs. You probably may heard that. And try to kind of build the open standard around those 3 types of signals, as we call them, that are then basically sent to some kind of a backend for processing and visualization. But that's not the end. Actually, the telemetry that is considered by this standard, or attempts that are being made for this standard, is also user activity. So anything on the mobile side, anything on the client side that you would also want to track and monitor and connect with the rest. Then call stacks or profiling data, call stacks, memory allocations, those are more for profiling. Most of you probably used Profiler before, but it's usually something that is kind of has to be set up. It takes some time. Now you can technically also have a profiling data, which is then associated with all the other signals, and that's also kind of in scope of the telemetry. And then there is also a whole set of different other considerations, like how to monitor a specific types of systems. Which is also coming, and also ability to interact with other protocols that are used for monitoring. The core aspect of OpenTelemetry is context, right? So that data is nothing, those signals are nothing new. You know it, we have it in the software industry for decades. But the problem is that it always missed the context. How to connect the data together, how to describe the system in a way that everybody will understand it in the same way. And the OpenTelemetry takes care of that. It takes care of that via specification. So obviously I don't have to probably mention that this is an open source project, fully open source. So specification is like a set of requirements that are describing basically how this whole space should work. It specifically also defines a protocol, so how to send this data. The protocol is called OTLP. And then also defines the API and SDK, and also provides guarantees on those APIs, SDKs, that once they are released as a major version, that they become stable, and that there is a guarantee that they won't be broken. Semantic conventions, which is something that is also kind of a part of the specification, is trying to describe the data. So, for example, describe how to model the messaging system monitoring, how to model a database, how to model a host. That's semantic conventions, and that's kind of a way of describing, hey, if you deploy your telemetry on the Linux or on Windows, you will describe this in similar way, and some things will be like mandatory to be provided or fetched and sent, or some things may be just optional, but still described in one way. On the left side, we have specifications, so more requirements, more standards. That's the part of the open standard, right? That it's attempted here. The OpenTelemetry is an attempt to create standard like that. The right side, so collector and instrumentations, those are things that are more an implementation by the community of that standard. Especially collector is important, because that's an attempt to create a universal agent that is capable of not only collecting data, but also doing lots of kind of a sophisticated processing, if necessary, and then forward that data in a uniform way somewhere into the backend for visualization. Collector is universal. That means that usually it runs on the level of the infrastructure. So this may be virtual machine, this may be a Kubernetes cluster, this may be some form of a runtime, right? Maybe bare metal, maybe your laptop or your desktop. But then usually the observability needs to go to get that full view, right? The view of the insights on the plane, how the plane operates, to understand basically what's the status of the plane with all its components. This is basically when instrumentation come into play. And instrumentation is basically language specific. So it's a set of libraries that are usually added to the project or run with the project or with a given application or service that are attempting to gather as much of this like a low-level data, which is then being used to kind of show basically what's happening in the application. Most of the major languages are covered. There should be no surprise that the Java is the most advanced implementation of the instrumentation at this point. And it comes in two flavors. First flavor is so-called auto-instrumentation. So something that technically allows you to add this instrumentation to your run command for Java and then automatically pick all the traces from the standard libraries that you would be using, standard frameworks. Actually, the amount of those frameworks that is already supported is quite significant. There is a whole registry of that you can review and find out whether libraries that you are using are already auto-instrumented. And that means that you can technically add this in literally minutes to your project without that much making any code changes, which is fine. Most of the cases, it gets you started quickly, but quite often the systems are not that simple, right? On top of the Java code that you've written, or in that Java code that you've written, there is also a business logic. So quite often, not all the things, not all the codes, not all the calls will be auto-instrumented. You have then option to add and customize by doing something called manual instrumentation. And that's the API and SDK part of the specification, which tells you how to do it for traces, metrics, logs, anything else, and allows you to enhance your automated collection of data with something which is more specific to you. Maybe a trace for a specific method or library that somebody written in your company or in your team. Maybe a metric that is needed by somebody on the business side, right? That really kind of is up to you to decide how you want to send it. And it shouldn't be that different from the techniques and tools that you already know, whether they are like existing metric libraries like Micrometer or tools like Prometheus. The approach is very similar. What connects those things is the fact that all of those things are always have the attached context, right? And we'll talk about this in a second. Observability backends are also part of this whole story, right? In order to have the observability on top of the OpenTelemetry, which is your getting data in, right? So this is the part which gets the data out of your system. You need to have an observability backend. And observability is not always understood by all the different kind of vendors or communities that are producing those solutions the same way. Technically, the observability should have application performance monitoring, infrastructure monitoring, log support, and real user monitoring, because that gives you the end-to-end view. So infrastructure will give you where you are running this, what's your kind of execution environment, what is happening with this, will allow you to then look into the inside of the software which is running on that execution environment, and that's the APM, which is more focusing on the software itself, on its structure, on what the software is doing. The logs are still one of the most important pieces of this whole solution, and this is usually where lots of observability backends will struggle, because logs are like a depiction or projection of the developer intention, because they were put by the developer
intentionally into the code. And quite often those logs stay unchanged, even though the whole kind of a system, the whole execution environment changes. Because, for example, Java evolves, Java runtime evolves, because you added new versions of the libraries. Maybe you exchange the database in the background because you have a very nice abstraction layer for your database. So logs will quite often stay the same, but some of the aspects of the profile of the execution of your system may change, and the APM and the infrastructure should cover that. The logs should cover still your intention of what this software was supposed to be doing. And the real user monitoring, obviously, most of the systems that we are building has some interaction with the users. And then basically whether this is a mobile device or a web client or any other type of application for clients may be necessary to have it in this. Then the protocol, universal agent, and the instrumentation. Why I made this slide a little bit agnostic to OpenTelemetry, because next to the OpenTelemetry there is a set of solutions coming from different vendors. Maybe some of the solutions which remained even after the OpenTelemetry was created. So quite often you may find potentially solutions that are comparable, but then I believe that OpenTelemetry is the most complete version of it. And given the pace and the progress that we have, I would say that the OpenTelemetry is quite a safe bet if you want to kind of consider how to start with the observability or build or change your observability solution. Why should you care? And who should care? Developers, DevOps, operations, support, business, cybersecurity operations. Actually, technically, all of those roles to some extent use already the whole concept of monitoring and observability. They are doing this on different levels based on their roles. Therefore, they will be interested in different aspects of those signals. But pretty much, I would say that observability is almost for everybody. Everyone in the organization probably will have a benefit of using the observability in some way. Going a little bit deeper into actual examples. So most of the examples with observability starts with this. There is some backend, and usually it starts always with the backend, which I think is incorrect. Then there is a simple single container Java application running on some Kubernetes cluster, and it's very, very, very basic kind of example that most of the vendors or most of the pages will start with. Fine, but actually that's not realistic at all, right? Like even small system will have number of different components, and even if you are running as a core Java company, it's quite possible that you actually have other technologies as well, right? So now you need to also instrument other technologies which are part of your tech stack, even though the Java is in core of your system. And those may be all the other languages and code written in different languages, like the client interface on the web in JavaScript or some kind of a framework on the JavaScript. There may be somebody who tried the Node.js first, and maybe some other team has used the technology, different technology, maybe Node.js, maybe something else. And then obviously you have the runtime, right? And this runtime doesn't look like just a single Kubernetes cluster. It's usually a little bit more complex. And then even more, most of the companies will have some exposure to external services, right? So you need to be able to actually monitor all of this. But actual case of an existing production system is closer to that, right? If you have a little bit more complex environment, if you have customers, if you are running beyond kind of a localized market, maybe you are in multiple countries, maybe you are in different continents, you will have your workload much, much more complex, and you will have apart from the development team or engineering team who is building the initial core code on Java or those additional technologies, you'll have a whole set of roles in your organization which are responsible for making sure that your system works, right? So system reliability engineering, making that your components get deployed in a proper way, so DevOps, right? Sometimes those roles are connected or overlapping in some way. You will have the developers, and then you will have the business and support, right? They also need to exist, right? All of them will want to know at some point what's happening with the system or what's happening in the system for a specific customer. And they will try to get information out of it. Then the approach to that, and the approach that most of the customers is taking, they know that the value of monitoring, they know the value of observability, so they go on and try to start with the backend. Let's say that they take this nice one, which is here, which is in this case the Splunk backend. Fine, you took this, you started deploying this, and now consider this: you have one backend instance and hundreds of places where you need to put your instrumentation in. So technically, in a complex system, you'll have much higher effort for putting your GDI or getting data in components in than kind of using or setting up your observability backend, because it basically will go everywhere and will interact with your entire system. A thing to consider also is that, and this is based on the internal telemetry of our customers, that collected just recently. So out of the observability customers that we have, 69% of them have Java and use OpenTelemetry Java instrumentation. No surprise there. Java is the most popular, especially among the microservice customers. By far, it's the most kind of a typical type of system that we see. Obviously, done in different ways, using different frameworks, libraries, and things like that, but most of the customers will have Java. Then out of those 69% customers, at least 63% is instrumenting at least one additional technology. Most of the time, it's JavaScript related. That means that they are most likely having observability for some of the client side. Some of them will, in that 63%, will probably be like Node.js, other things. We see also lots of Python customers, Java core, and then the Python as a supplement. And out of those 69%, 38 has 2+ technologies. So not only Java, but a couple of other things that they are trying to observe. That should tell you that even though the core is Java and it's a core part of the solution, this is not the entire ecosystem. So in summary, consider this: if you have one backend and so many kind of places where you need to put your instrumentation to get the full view, then actually implementing and replacing later your GDI components will be extremely expensive and quite often will be a deal breaker and will not allow you to even move to something new, right? All right, time for another quick check of whether you are sleeping or not. A riddle. So glasses and Java. Why do the Java developers wear glasses? So they can C#. Just for the record, I've been a software engineer on Java for 17 years. So it's good to put a distance about yourself a little bit. Observability backends these days comes in different ways and different forms. They can be in-house solutions. Quite often, actually, it happens quite often. Open source. Managed, that means that it's open sourced, taken by some company, put into the cloud and put as a managed service with some support. Cloud native, commercial, of course,
because this is a large kind of a market. And then multi-vendor. We'll focus on those gray ones, but I think that below the line you can see all the different types of instrumentations that those backends kind of run, right? So some of them are native or in-house or vendor-specific solutions. Some of them are based already on OpenTelemetry. You can see the adoption pretty much across the different types of the backends. So from those managed cloud native and commercial, you can take a look at, for example, AWS solutions, and AWS has actually two types. So they have a managed service, which is based on Grafana and Prometheus, which you can also install yourself and run with the OpenTelemetry. They fully embrace the OpenTelemetry. The same goes for their native solution for monitoring, so CloudWatch and AWS X-Ray. They also kind of support the OpenTelemetry. But also the CloudWatch and X-Ray have their own agents, right? Written by Amazon, which are Amazon specific and are also quite often used, right? But recently, AWS decided that they will also fully embrace the OpenTelemetry and give option to customers to use the OpenTelemetry as a method of getting data into those systems. Splunk has observability, which is also available on the AWS as a solution. This is an example of the commercial one, right? With like a full OpenTelemetry support. And you can find a lot of those systems out there, but almost like it's quite possible that if you look into the documentation, that the common thing that connects all of them is OpenTelemetry. So I would like to propose that whenever you have a discussion about how you build your observability, you shouldn't start with any vendor. You shouldn't consider features that they offer. You actually should start with the thing that will cost you the most, which is how you will get your data out of your system and how you will maintain this going forward. And I believe that starting with OpenTelemetry is always kind of a good choice at this point, because you have lots of flexibility, lots of coverage kind of out of the box. And then the nice thing about the observability is that you can choose your backend, right? So you can fairly easily, with the configuration files, just kind of point to different place where you will forward your data. You can even do a double publishing approach, right? So publish to one and another. You can even do the multi-vendor solution, which I have mentioned a sec before, where parts of your data go to one solution and parts of the data go to another solution. Why would you do that? I don't know, but I know that there are customers who are doing things like this. And then repeat the step 2, because it's just a single thing that you need to replace. You just need to replace one backend, not hundreds of instrumentation agents. All right, so Java ecosystem a little bit deeper. So when we think about the Java ecosystem in OpenTelemetry, we consider following things. Obviously, there is a Java code running in the Java runtime directly, using different type of runtimes. That definitely is not the full list, but those are, I believe, very representative types of execution or the runtime environments where you can see and deploy your Java today, especially in the cloud. So you have the virtualized environments, you have the containerized environments or containerization clusters and containerization orchestration and management solutions. You may also have a serverless, right? So functions, they are pretty much present on most of the cloud solutions. But that's usually not enough, right? You also will have the client side of things, right? In your Java core solution, there is quite often a web client, and that web client doesn't run on Java. It runs usually on a JavaScript. So you will have a browser with a JavaScript, which you also need to consider into this picture. And then you have quite often mobile applications. I specifically refer to Android because it shares a common heritage with the Java.
and it's also part of the OpenTelemetry. For this ecosystem, you have to consider 3 additional things. So first is the observability backend, right? Because you need to send it and visualize and manage the data somewhere. Then you have the OpenTelemetry collector as this universal agent, which will take care of aggregating and then forwarding the data in a uniform way and reliable way to your backend, potentially with a high level of control over what happens with that data before it's forwarded. That's an important piece, but we will not go into detail today. And then you have the instrumentation, right? That instrumentation will be usually called Java instrumentation. Most of the time you will run it in form of a Java agent with the auto instrumentation enabled. And you will deploy it across those different types of runtimes and deployment methods, using the tools, tools that you already use to deploy your own code to those different runtimes and those different locations. So if we are talking about the EC2, or in this case virtualized environments and like virtual machines, usually the usual pattern is to deploy the collector, 1 per machine, and then the number of instrumentations depending on how many processes, Java processes, will run on that machine. Maybe something heavy, maybe a couple of smaller things, maybe some sort of a old school application server. You would deploy then the collector as a 1 single instance, and then you would attach the Java agent to, usually as a run command, to every process that you are interested in monitoring. Fairly straightforward. Java collector is very easily added or integrated into the typical CI/CD pipelines. It's fairly also easy to deploy. It's kind of like a single command. I think I have a screen later on this. And then the Java instrumentation is pretty much 1 single jar, which is added to a run command, and can be controlled quite often with single either environment variables or system properties. Or if that's not enough, then there is also a ability to support or to control the behavior of the Java instrumentation with the config file. Situation gets a little bit more complex if we are talking about containerized environments, because that requires some coordination with the orchestration service. So that usually is deployed in form of for Kubernetes, in its form of the Kubernetes operator, OpenTelemetry operator for Kubernetes, which takes care of deploying an instance or 2 instances actually per cluster, just to make sure that both the cluster level information and the nodes and pods and container level information are also collected. An operator is also capable of doing automatic detection of the services which are running in the containers and automatically injecting that auto instrumentation. So pretty much with one command, you can deploy almost the entire instrumentation to your entire Kubernetes cluster. That's not a coincidence. Like lots of the OpenTelemetry concepts were built around the microservices. So obviously, like Kubernetes or similar containerization environments will be included. There is also an ability to use Helm charts to deploy collector, but then the Helm charts on their own, like the default one, it's just deploying the OpenTelemetry collectors. If you want to add something more like specific instrumentations, you just need to do it yourself. The next one are Lambda functions, or basic generally functions. So in this case, if you are writing your serverless function in the form of a Java, Lambdas offer you something called layers, right? So you, instead of adding your instrumentation and the entire code into the Java code of this function, you would just basically add in the configuration level, on the configuration level, the definition or the ARN of the layer where you already have a pre-built instrumentation and collector, which will take care of instrumenting your Lambda. So it's fairly kind of easy because it's just a simple copy-paste into this one. Going to the client side, there is also Android, and Android shares lots of the instrumentation components with the Java instrumentation, but it's also kind of a modified, and it's being constantly modified to be rewritten more into Kotlin implementation. And pretty much on the Android side, we can get all the information about what's happening with the mobile applications running on the device and some aspects of the device itself. And for Java web client instrumentation, you would use a JS web package or part of the JavaScript instrumentation, which is specifically designed to capture the user activities on the website. And basically the difference between the client side and services or the backend side is that in the backend side, we always recommend in OpenTelemetry to use the collector as your gateway, because the collector takes care of the offloading the data through the network and can easily and quickly collect the information both from the instrumented services as well as the actual runtimes themselves. So because the collector is not only channeling the data, but it's also capable of collecting information from the runtime itself. So deployment, not that visible, unfortunately. The deployment commands are usually just one-liners, so it kind of gets you quite quickly. Since there are one-liners, then usually they are easily integrated with the tools on the automation tools and the integration tools. Then the main control of the entire OpenTelemetry comes through the form of the YAML files, which basically tell the collector what to do with the data, how to receive the data, how to collect the data, how to process, and then export or where to export. And those YAML files are extremely powerful because, like I said, they allow you to dictate and set up policies where you will send the data, how you will send the data, whether you will duplicate the data or not. And then most of the time, the configuration of the instrumentation itself comes in the form of the either environment variables, sometimes configuration files, system properties, especially for Java. So pretty much with those three sections here, you can use that to almost instrument everything in your environment based on this example here. So in summary, as we are running out of time, observability is for everybody. So quite often, many teams, many roles will use some aspect of observability in your organization. Context is super important for the observability because the only thing that makes this different than the typical techniques of monitoring is the fact that everything, all the pieces of the data are connected and then can be easily correlated on the backend side. You should take care of this strategy of how you're doing observability. So don't lock yourself in. So instead of choosing from the observability solution backend, try to go through the GDI first, which is the right strategy. And OpenTelemetry is always your safe bet going forward. If you want to know more, if you are based in Belgium, there is a nice Observability for Rookies workshop, which is held in Brussels. There is also a virtual recurring event for the same. It goes through the very hands-on kind of example how to start with the observability. You can then try out the different kind of backends there. Then OpenTelemetry has a very nice, compelling demo which you can deploy on the Kubernetes cluster. And then I also kind of encourage you to take a look at different distributions of the OpenTelemetry, like the one which was done by AWS, right? So that should give you enough of the information on how to start, but also enough of the information on how this OpenTelemetry works across different solutions from the market. And thank you very much for attending and listening. I hope that I didn't kill you with my corny jokes. I was expecting more boos on C#, but okay, I take it. If there are any questions, we are kind of out of time, but I am still at the booth, so you may find me there, and I can answer and give you more details as needed. So thank you very much.